Using the trapezoidal rule with 3 trapezoids, determine the first quadrant area under f of x. This is a quadratic equation here, and I got a negative in front of the x squared, so it's going to be a quadratic open downward. So to factor this thing out, I'm just going to guess it here. I need an 18. Well, I can see that it's going to be x squared, or negative x squared here, so it's going to be x, and one of them is going to be negative, one of them is going to be positive. That's the only way you get a negative x squared there. Because I want 3 here, I know I'm going to have 6 and 3. That 6 and 3 make 18, but when you subtract them, you get 3. So I want negative 3, so that means that the 6 has to go with the negative x, and the 3 with the positive. That gives me negative 3, negative x squared, and 18. So that is our factored form. This tells me that it has zeros at x equal to negative 6 and positive 3. So to get kind of an idea of what this looks like, it's not going to be exact, but it's going to look something like this. Let me do a little bit bigger here. 1, 2, 3. So I have to draw the trapezoids. Let's see, 1, 2, 3, 4, 5, negative 6, 3, and it's going to be up. It's probably going to be pretty tall because they're pretty far apart. It's going to be, so I mean, something kind of like this. That's the idea. And we're only concerned about the first quadrant, so we're only really concerned about this area here. And we went 3 trapezoids, and you can see there are 3 positions. This is where it crosses the x-axis. So each one of these trapezoids is going to have a height of 1. And really, we're just looking for what's this length and this length. We have the height, this length here, and this length. And then this last one's actually not going to be a trapezoid. It's going to be a triangle. But these first 2 will actually be trapezoids. So that's all we're trying to find is this trapezoid, and this triangle added up. Okay, to find those, I need to find this height, and this height, because this one is at 0. This first height happens when x equals 0. The next one happens when x equals 1. And the next one happens when x equals 2. Plug 0 into there, we're going to get 18. 18, that's this first height here. I'll just write down here. 18 is for this first height. This second height here, plug 1 into there, we're going to get 18 minus 3 minus 1. It's going to be 14. And for x equal to 2, the function hits 3 times 2 is 6. 2 squared is 4. 6 and 4 is 10. So off that's going to be 8. So my drawing is pretty inaccurate. But that's the idea. Okay, so really what we're looking at here is we're going to get an approximation for the integral from 0 to 3 of our function f of x. And so this is approximately equal to the area of this trapezoid, the area of this trapezoid, plus the area of this triangle. Now the area of a trapezoid is just the averages between the 2 bases. This is going to be base 1, this is base 2, and then the average between those, that gives you kind of a square, and then times by the height. That's how you can find the area of a trapezoid. So we're really going to do base 1 plus base 2, the average of that, times the height. That's the area of a trapezoid. So this first one has a base 1 of 18, a base 2 of 14. So we're going to 18 plus 14 over 2 times a height. The height is just 1. The second trapezoid has a base 1 of 14, same base as base 2 of the other one. And then the second base is going to be 8 times a height of 1. And then the last thing is a triangle. It's not actually trapezoid. Triangle is 1/2 base times height. That's the area of triangle. The base is going to be this base here. And that base was 8. So 1/2 a base of 8. And the height of the triangle is 1. It's just right, just on its side. So this is 8 and 1. But you're going to rotate it over this way and fit it right into there. So that's going to be a height of 1. Okay, so this is going to be 18 plus 14 is, let's see, 22. 32 over 2 is going to be 16. Times by 1 is just 16. 14 plus 8 is 22. Plus over 2 is 11. And 8 over 2 is 4. 4 and 16 make 20. And 11 make 31. That is our answer.